Analysis of flammable refrigerant leaks through CFD simulation and risk assessment to enhance industrial safety. Team, ReflowSafe. Project objectives. Simulate refrigerant leak scenarios for ammonia and propane under different scales and situations. Analyze dispersion patterns based on leak location, ventilation, and external factors, like wind, temperature. Identify potential danger zones. Compare current industry safety protocols against simulation results. Propose improvements for industrial facility designs and emergency response plans.
This is the plant we used for the simulation. The name of the company is Saputo Dairy Foods and it is located in Tulare, California, USA. The real plant can be seen in left-hand side and the SolidWorks model can be seen in the right-hand side. This is the methodology part. Here the process divided into 4 parts. First one is design phase. In the design phase identified safety issues related to ammonia and propane. Atmospheric data, cloud, wind speed, direction, humidity, temperature, is collected and get the average values of it. You can see the graphs used to obtain average values in the background and finally builds up basic simulations and selection of the plant done. Second one is implementing phase. In this phase Aloha simulations are run and disperse area is estimated. Then perform CFD modeling and simulation for the plant. Next phase is testing phase. In this phase compare simulation results by simulating for different hole sizes and different tank sizes of the gas tank. Then identify the communities exposed and hazardous zones. Last phase is evaluation phase. In that phase HAZOP for ammonia and propane was created and suggest safety improvements for selecting tank sizes for a plant to store ammonia and propane. Let's go through the results of this project. For each instance let's study the Aloha results. Horizontal spread at 2 meters height from ground, and the mass fraction of leaking gas along a line downstream of the wind direction for maximum spread. Here we can compare the Aloha result, simulated spread and the concentration levels downstream of the wind for 256 kilograms ammonia with 5 centimeters hole. Flammability and toxicity are 2 key safety concerns in industrial settings. Flammability hazards are defined by the lower flammability limit, LFL, the minimum concentration at which a substance can ignite. Ammonia has an LFL of 15% by volume, or 9.39% mass fraction, while propane's LFL is much lower at 2.1%, or 3.16% mass fraction, making it far more flammable. Toxicity hazards describe the health risks from exposure. Ammonia can cause irritation at just 25 ppm, equivalent to 2.4 times 10 to the power of 5 mass fraction, with life-threatening effects above 300 ppm. Propane is less toxic, with 500 ppm triggering mild symptoms, or 7.6 times 10 to the power of 4 mass fraction. In short, ammonia is more toxic, and propane is more flammable, requiring different safety strategies for handling and storage. In the charts, the mass fraction is in log scale and the lower flammability level LFL and the toxicity threshold are indicated. By obtaining such plots we can observe how the community in that particular direction gets affected by the leakage. For each case here, we can see that there are stagnation points due to buildings at some locations downstream of the wind and also on the 2D contour. Such places must not be considered as emergency assembly points. Moreover, this emphasizes the importance of open spaces with minimum resistance to airflow when maintaining large refrigerant reserves. With this analysis, important information can be gathered. It can be noticed at what radius from the source a leak would be intense enough to be over the toxicity threshold and lower flammability level. It can be observed if the neighboring areas are affected by toxic hazards or fire hazard at different leakage amounts and hole sizes. To analyze how a process or system can deviate from its intended design or function, and what the consequences of such deviations might be, especially those that could lead to safety risks, environmental damage, or operational failures. HAZOP is applied to both propane and ammonia systems to identify potential risks such as leaks and operational failures. It helps implement corrective measures, effectively reducing the overall risk and enhancing system safety. Here the things to do to avoid is discussed.